Hey, high school chemistry teachers. I'm Kendra, creator of ChemEd Solutions, and it's my mission to change the narrative of high school chemistry from yuck to yay by designing student and teacher materials that allow you to focus on what matters most, getting all your students to be confident and successful without the burden of using your personal time to do so. I support you by giving you my best proven tips vetted by thousands of students, parents, and case managers. So today's tip is from our unit on gases, looking at gas variable charts. Now, gas law calculations can be a nightmare for the unorganized. With upwards of 6 different variables in each calculation and varying units, one can get numbers mixed up in a hurry. So enter the variable chart. It slows our students down to help them read the prompt for information, helps them focus on units, decreases overwhelm, and keeps them organized, which is a win for everyone. So what does this chart look like? Well, they look like this. And in these charts, we'll get down to practice in a second. In these charts, there's always two columns. So column 1 and column 2. Column 1 is initial and 2 is final. Now, the reason I don't use initial and final is because 1s and 2s match our variables in our formulas for our basic gas laws. P1, V1 equals P2, V2. Variables are lifted down the left side, and I always do pressure, volume, and temperature. And the reason I do this is because PVT is in the same order as the ideal gas law, PV equals nRT. Temperature also is at the bottom to give space for turning our degrees Celsius, which is usually the temperature units given in a problem, to Kelvin by adding their 273. I tell students to use an a question mark for the variable that they're trying to calculate instead of an X because I don't want to add in another letter for them. That can get confusing. And then also we're going to substitute in the actual variable that we're looking for in our problem. Then have them draw a horizontal line through the variables not used or ones that are said in the problem but stay constant so they know that they don't need to plug them in. So what would this look like for a student? So if I ask a student to create a variable chart for the following combined gas law calculation, I'm telling them that I have an ideal gas law and a 50 milliliter canister is sitting on a shelf at room temperature, in a room at 21 degrees Celsius and 1.5 ATM. The chemist takes a canister and warms it to 25 degrees Celsius. Now, if the canister can handle up to 2.5 atmospheres, will it explode or stay intact? Now, a situation that in reality is not going to happen, but you want to get some kids excited about a chemistry calculation? Ask them if something's going to blow up. They're in it. So pull out our variables and set up our chart. So we set up our chart, 1 and 2, draw our line, and then our variables, pressure, volume, temperature, ideal gas in a 50 milliliter container. Here's my volume. Now it's in both of them, but you might find that students, they're just picking it up to first, starting here, so it goes here. Sitting on a shelf at 21 degrees Celsius and 1.5 atmospheres. So they fill those in. The chemist takes a canister, warms it to 25. Can it handle up to 2.5? Now, even though we're given this, that's not the final pressure. I want to figure out the final pressure and compare it. So looking for, will it explode or stay intact? What will its final pressure be? That's my question mark. And then my volume, because it's staying in the canister, stays the same. So they could write it like this, or they say, hey, this is staying the same. So it's the same on both sides, gets knocked out. It's constant. We don't have to worry about it. And then this gives them room to add their 273 to turn it into Kelvin. So again, I ask my students to do this, and then I prompt them to write it in their classwork and on at least the quizzes that I do to check their understanding. When it comes to the final assessment, I don't make them do this, but most of them are in such a habit of doing it that they just sketch it right away. So to never miss a weekly teacher toolkit tip and get access to a PDF copy of both the teacher and student versions of this, I have a student version that you can use right away in class. Sign up for my email newsletter at chemedsolutions.com/chemguide. In addition to weekly teacher toolkit tips, when you sign up, I have a few gifts just for you, including a high school chemistry course outline, a pacing guide, a unit checklist that you can use in any unit that you teach in, and my personal teacher planner to keep yourself organized, less stressed, and enjoying life. Thanks for joining, and happy sciencing!